The next part in this chapter is about resistors connection. You can connect circuits or resistors in parallel or series or whatever. So we need to know what's the meaning of series, what's the meaning of parallel, and so on. Look at this slide here. We have a series connection. In series connection in general, what is unique about series connection is that the current does not change. The current does not change. That's why I say that, okay, if we have a node like this, that's connected to two branches on it, or two elements only. So in this case, the current will not change. Like this one here. Here also you have this one, you have this one. Both of them, they are connected to two branches. So in this case, let us call it a series node. So if you have some series node like this, you have series connection. So you see here, the current in the blue one is the same like the current in the red one. And here, the current in the blue is the same like the current in the red, the same like the current in black. If you look at this one here, all these nodes are series connection except these 2 points here. These 2 points are not series connection. Why? Because they are not connected. They are not connected to 2. They are connected to 3 or more. Here they are not connected to 3. So actually they are dividing points. And if they are dividing points, this means that the current will split, will change. So these are not series nodes. Then you don't have series connection. Okay, so if this is a series connection, this is a series connection, then this blue and this red and this blue are connected in series. And then the series connection is cut here. For same for this three also. This red, this black, this red are in series. This blue and this red are not in series. Why? Because there's one node in the middle that's splitting point. And from when you look at it, of course, the current is different. The current here is different from the current here. If you have a current here, the current will split in this two. Okay, same for this one. Same for this one. And the relationship between if you want to calculate the total resistance of number of resistors connected in series, it's very simple. All what you have to do is just add them. For example, if you have a 10 ohm and 20 ohm, like this, they are connected in series. What's the total? It's 10 times 20 plus 20. 10 plus 20, which is 30. And if you have three resistors in series like this, 2, 3, 5, you add them. 2 plus 3 plus 5 equal 10. So if you look at these examples here, and we need to find the series connections, the resistors that are connected in series. Here, for example, you will not find any resistors in series except okay, except what? Except these resistors. 1, 2, 3. These three resistors are in series. Why? Because all other resistors here are connected through splitting points or splitting nodes. R1 and R5, for example, R4, they are not in series. Why? Because there is a splitting point here. There's a splitting point. There's a splitting point. There's a splitting point. Then you cannot consider any of these resistors in series. But here, these two are connected. This is a series node. This is a series node. Look at this one here. This is a series node. This is a series node. Okay. This one is a series node also. This one is a series node. Then these two are in series. These two are in series. And these three resistors are in series. They are all in series. And when you think about them, you will find that the current in each series resistors, each of them, the current will not change. It's the same. The current in R1 and R4 are the same. The current here in R1 and R4 are the same. The current in R2 and R3, R5 is the same. The current in R7 and R8 and R9 is the same. For example, let's look at this one here. This all of this are in series. If you have a current here, the current will not change. It will be the same. Okay, that's it. You don't have any other series connection. Why? Because this one is not a series node. This one is not a series node. For this one here, all of them are in series. All of them are in series. And if you have a current here, the current is one current. You don't have any splitting points here to divide the current. If you look at the this example, let's highlight. So for example here, these two are in series, right? Do you have any series connection here? No. Do you have any other series connection? No. So this is the only two resistors that are in series. You don't have any other series nodes. And if you look at, for example, where are the splitting points or the dividing points here? This one is a dividing point. It's connected to 3. This one is connected to 3. This one is connected to 3. This one is connected to 4. This one is connected to 4. That's why you don't have any series node here, except these two. You do not have any series connection except for these two. Okay. Next part here is called the voltage divider. And the voltage divider, you can use it, you cannot. If you don't want to use it, that's fine. Okay. So it is any problem, as I said, you can solve it using the 3 basic laws. But voltage divider can sometimes make it easy. If you have a resistor, if you have a source like this, and it is connected to some resistors in series. Some resistors in series. Then you can calculate the voltage across the individual resistors, like V1, V4, V6. I called it V4 because it is the voltage across the 4 ohm, and V6 the voltage across the 6 ohm. Okay, so how do you calculate it? You have to use this formula here. This formula. Vn, which is the voltage across the resistor number n. Vn, V4, V3, V5. Equal what? Equal Rn, so R for this resistor, divided by R total, RT, which is the total resistance, time the voltage, total voltage. So for example, what is V4? What is V4? So let us see here. V4 equal what? According to this. Equal Rn, what's Rn? Rn is 4. Rn is 4 ampere, 4 ohm. Divided by the total resistance. What's the total resistance of 4 and 6? It's 10. 4 plus 6, which is 10. Let's write it here in details. So this is the total resistance, 4 plus 6. Time V and V total. V total is what? The total voltage is 5. So this 5 volt is divided between a number of resistors in series. So this is how you calculate it. And so on. If you want to calculate V6, what's V6? Is Rn is 6 ohm. The total resistance again it is 4 plus 6 or 10. The total voltage is 5, and so on. And if you want to calculate them, you will see that the summation is 5. For example, here 4 times 5 is 20. 20 divided by 10 is 2. So this is 2 volt. What about this one? 6 times 5 is 30. 30 divided by 10 is 3. Okay. Now if you look at this results, 3 plus 2 is what? Is 5. And it must be 5. Because you have 5 volt source divided between 2 resistors. So if one of them is 2, the other one is 3. 2 plus 3 is 5. And you can use Ohm's law. If you want to apply Ohm's law here, you can. Because here, you can calculate the current. What's the current here? The current is 5 volt divided by 10 ohm. The resistance is 10. You have one resistance here, or the total resistance is 10. So the current is what? 5 divided by 10. 5 divided by 10 is 0.5 ampere. The current is 0.5 ampere. Okay, and once you know the current, you can calculate the voltage. Okay, the current is 0.5. and the resistance is what? Is 4, for example, here. So can you calculate the voltage? Yes, 0.5 times 4 is 2. Same for this one. For this one here. The current is 0.5 and the resistance is 6. 0.5 times 6 is 3. So as I said, you can use voltage divider, or if you don't want to use it, that's fine. Parallel resistance or parallel connection. Parallel connection, if you have resistors connected from both sides, they must be connected from both terminals. Both. They cannot be connected from one only. Okay, so you have to be careful. The word parallel here does not mean parallel geometrically. They are not parallel geometrical like this. They are parallel means that they are connected from both terminals. And if they are connected from both terminals, this means that the voltage across them is the same, because the two terminals are connected. The two terminals are connected. Okay, since the voltage is the same, not the current. In series, the current is the same, but in parallel, the voltage is the same. So look at this, for example, here. As you see, these two resistors are connected from here and here, since they are in parallel. These two are connected from here and from here. These three, since they are connected in parallel. So now let us see, do we have any resistors in parallel in this circuits? Yes. Let's see. For example, here, do we have any resistors in parallel? Can I say, for example, that R3 and R6 are in parallel? No. Why? Because these two are not connected. As I said, they must be connected from both terminals. And connected means wire. Okay, connected. Wire, with wire. They are not connected from here. They are not connected from here. Then you cannot say that they are parallel. So some common mistakes that some people believe that, oh, if they are like this, they are in parallel. As I say, parallel does not mean that they are parallel geometrically. They are parallel means that they are connected from both terminals. So you have to say that this is not right. This is a mistake. Same also if you said, okay, R7 and R9, they are not in parallel. R7 and R9 are not in parallel. Why? Because they are not connected from any two sides. So no parallel connection here at all. There's no parallel connection. You cannot say also that R, for example, 1 and 2 are in parallel. They are not connected. Okay, they must be connected from both terminals. So let us see, for example, in this one here. Can I say, for example, that R3 and R6 are parallel? Yes. Why? Because they are connected here and they are connected from the other side. That's it. That's it. So R3 and R6 are parallel. Okay. Any other resistors are not in parallel. For this example, these three are parallel to each other. Why? Because they are connected from here and they are connected from the other side. You don't have any other two resistors in parallel. Okay, on this circuit. You cannot say again R4 and R5 are parallel. You cannot say that because they are not connected from both terminals. Okay, what about this, for example? Do we have any two resistors in parallel? Yes. Here we have these two resistors in parallel. See, the same two resistors which are in the first example. Okay, what happened here? Why here it is right and here is not right? Because I removed R4 and R5. Okay, now you see they are connected here. They are connected from this terminal and they are connected from the other one. So now you can simply say, you can say that R3 and R6 are parallel to each other. Why? Because they are connected from both terminals. Let us see this example. Do we have any two resistors in parallel? Yes, of course. 5 and 20 are parallel to each other. 12, 4, and 6. The three resistors are parallel to each other. They are parallel. Okay? But you don't have any other resistors in parallel.